Hello everyone, here is another video with OrgTube channel. In this video, I'm going to explain how we can calculate molecular formula by rule of 13 and also how we can use interpretation of mass spectroscopy for identifying presence of chlorine and bromine in our compound. For beginning, I would like to explain what is rule of 13 and how we can find the molecular formula for a compound with molecular weight of 104. We know mass of carbon is 12 and mass of hydrogen is 1. Rule of 13 used to find molecular formula by dividing our molar mass or molecular weight by 13 because 13 is mass of CH. So 104 by 13, the answer is 8. 8 times 13 is 104 and remainder is 0. 8 is quotient and it tells us we have 8 of CH in our molecule. So we have 8 of CH, or we can write C8H8. Here is the next example. Again, rule of 13. We have 106 divided by 13. The answer again is 8. And here we have 8 times 13, 104. And remainder is 2. Then we can say that quotient is 8, so we have C8H8, and remainder is always number of hydrogen. So we have 2H, I'm writing H2 here. The answer is C8H10. It is always good to calculate degree of unsaturation. If we have degree of unsaturation negative, or if we have fractional, it means something is wrong with our calculation, or we may have other elements in addition of carbon and hydrogen in our compound. Next example, 120 divided by 13. Quotient is 9. 9 times 13 is 117. Then the remainder is 3. So the formula, we can write C9H9 from quotient, and we can write H3 from remainder. Then the answer is C9H12. And here is a formula for this compound. This example is a little different. We have 128 and we divide it by 13. Then we have 9. Then 9 times 13 is 117. Remainder is 11. So we may write C9H9. Then we also have 11 hydrogen from remainder. Then H11. The answer is C9H20. C9H20 is an alkane and it is the formula for no name. But rule of 13 is an estimate. We may have more than one suggestion by using rule of 13. We know mass of carbon is 12 and mass of hydrogen is 1. So 1 carbon is equals to 12 hydrogen, and we may replace 12 hydrogens with 1 carbon or 1 carbon by 12 hydrogen, sometimes in the formula. In this case, we have 20 hydrogen here, and we can take 12 of them and instead put 1 carbon in our formula. So if I subtract 12 hydrogen and instead I add 1 carbon, the formula will be C10H8. This formula is for another compound, naphthalene, and its structure is in this form. So we can clearly see that we have two different compounds, both of them they are existing with different formula and with same molar mass. So we always have a series of possible formula for our compound. In this example, we know we have two oxygen in our compound and we only need to calculate number of carbon and hydrogen. The molar mass for this compound is 88. When we know number of some elements, heteroatoms, like oxygen, nitrogen, or halogens, it is better always to subtract the mass of those known elements from the total mass and do the calculation for the rest of molecule. So we know 88 is the mass of whole molecule, but we also know that oxygen is 16. So the answer is 56. So we know 56 is the mass of carbon and hydrogen in this compound, not the whole molecule. Then we do calculation on 56 using rule of 13, dividing 56 by 13. The answer is 4. Then we have 52 here. 4 times 13, 52. And remainder is 4. So from here, we have C4, H4. And from here, we have H4. And we also know that we have O2 in our compound. Then I add O2 as well to this formula. Then the formula for this compound is C4H8O2. There is also another rule in organic chemistry. If the mass of molecule is odd, it means we have odd number of nitrogen in our compound. So we may have 1 nitrogen or 3 nitrogen and so on. Let's just assume we have 1 nitrogen for this compound. But let's just have the simple calculation to see what's wrong with our answer. Rule of 13, 93 by 13. Then the quotient is 7. 7 times 13, 91. Remainder is 2. So we have C7, H7 plus H2 is C7, H9. Well, this formula is not right. If we calculate degree of unsaturation for this compound, this is the formula for degree of unsaturation, carbon plus 1 minus number of hydrogen plus halogens minus nitrogen by 2. If we calculate here, we have 7 for carbon, then for hydrogen we have 9 by 2. We don't have X halogens or nitrogen in this formula here. Then the answer is 8 minus 4.5, which is equals to 3.5. We cannot have fractional degree of unsaturation because degree of unsaturation is number of pi bond or number of ring in our molecule. So this formula doesn't exist. But we already know that because it's odd, we should have at least 1 nitrogen in our formula. The mass for nitrogen is 14 and it's equals to mass of 1 carbon and 2 hydrogen. Also, if we need to use for oxygen, which is not the case here, mass of oxygen is 16 and it's equals to 1 carbon and 4 hydrogen. By taking a CH2 and adding 1 nitrogen instead, the formula of this compound turned to C6H7N. And if we calculate the degree of unsaturation for this compound, right now it is equals to 4. And we don't have that problem again. And this is the possible structure for this formula. So for nitrogen is a little clear, but how about chlorine and bromine? To realize if there is chlorine or bromine in our structure, we need to take a look to their special pattern in mass spectra. Let's start with bromine. Bromine has two major isotopes in nature, 79 and 81. And they are roughly 50-50% in the nature. So whenever we see two peaks at the end of mass spectra, that they have almost same intensity and their difference is 2 units. This means we have one bromine atom in our structure. If we have more than one bromine, our pattern will be different. The first peak always is called M plus or parent peak, and the second peak is called M plus 2. Our calculation is always based on M plus, the first peak, and the first isotope. So our parent peak is 156, and we already know that we have one bromine. So let's subtract mass of bromine, 79, from our compound. The answer is 77. This 77 is mass of the rest of molecule, and we can use rule of 13 for calculation of molecular formula. 77 dividing by 13, quotient is 5. 5 times 13 is 65, and remainder is 12. This is a rare example because the remainder is 12. We always considering number of hydrogen for remainder, but 12 can also be one carbon. So we may have one carbon or 12 hydrogen in this case. Let's have both of them. So we have 5 for quotient, then our formula is C5H5. Then we may have 12 hydrogen as well. In addition of that, for sure we have one bromine in our formula. Then the answer is C5H17Br. This formula is impossible because we know the maximum number of hydrogen is for alkane. And if we have an alkane with 5 carbon, the maximum number of hydrogen is 12, and we have 17 here and also one bromine. But we can also prove that this formula is wrong by calculation of degree of unsaturation. If I calculate degree of unsaturation, here again is the formula for degree of unsaturation. H plus X, X is halogen and nitrogen dividing by 2. Number of carbon is 5 plus 1 minus number of hydrogen 17 plus 1 for bromine and nitrogen is 0. The answer is 6 minus 9, which is equals to negative 3. Negative 3 means we have negative 3 rings or pi bond in our system, which is impossible. So this negative 3 is another proof that this formula is wrong. So let's consider the other possibility when we have one carbon instead of 12 hydrogen. So again, we have C5H5 because of quotient, but this time instead of 12 hydrogen, I put one carbon here. And for sure, again, we have a bromine in our formula. Then the answer is C6H5 bromine. If I calculate degree of unsaturation, 6 plus 1 minus number of hydrogen is 5 plus 1 bromine. The answer is 4. And this is the structure for this formula. It is bromobenzene. So by calculating the degree of unsaturation, we can evaluate our answer. Let's have another example for bromine, then I explain chlorine. Here is the next example. Again, we can see the same pattern. The first peak is M, and second peak is M plus 2. We do calculation for M, so we have 122, and we know there is one bromine in this compound. So let's subtract mass of bromine, so minus 79 Please keep in mind that we use the actual mass of isotope, not the average mass in periodic table. 122 minus 79 is equals to 43. Then using rule of 13, 43 by 13. Then the quotient is 3. 3 times 13 is 39. Then the remainder is 4. So from quotient we have C3, H3, then we have 4 extra hydrogen from remainder. And of course we have 1 bromine as well. Then the formula of this compound is C3H7Br. And if we calculate degree of unsaturation for this compound, it is equals 0. So there is nothing wrong with this formula. Here is another example, but this example we don't have that pattern. This example is belong to the chlorine. Chlorine also has two major isotopes in nature, chlorine 35 and chlorine 37. But chlorine 35 is around 75% and 37 is around 25%. So we see two peaks, that the first peak, which is belong to the compound containing chlorine 35, is roughly 3 times greater than the second peak. But still their difference is 2. So the first peak here is M plus and the second peak is M plus 2. And we see the 112 is almost 3 times bigger than 114. This pattern is also unique for one chlorine atom in molecular compound. If we have more than one chlorine, the pattern will be different. The calculation for molecular formula is exactly like bromine. We have to use parent peak 112 and we need to subtract mass of chlorine, but the first isotope 35. So 112 minus 35 is equals 77. Then 77 by 13, 5, 65, and 12. This example is like the first example for bromine, and we know for 77 we cannot have 12 hydrogen. So this 12 is belong to one carbon. So from quotient we have C5, H5. From remainder we have another carbon. And of course this compound has one chlorine. So the compound formula is C6H5Cl, and it's belong to chlorobenzene. And here is the last example. The last two peaks we see in this spectra, they are 78 and 80, and the pattern is again 3 to 1. 78 is 3 times greater than 80. So 78 is parent peak and 80 is M plus 2. So we do calculation based on 78, then minus mass of chlorine 35. The answer is 43. Then if we divide 43 by 13, rule of 13, we get 3 for quotient and the remainder is 4. So 3 for quotient means we have C3H3, 4 extra hydrogen from remainder, and of course we have one chlorine in our compound. Then the formula for this compound is C3H7Cl, and one of the possible structure for this compound is 2-chloropropane, and degree of unsaturation is 0. Thank you for watching this video. To watching more video, please subscribe to this channel.